These problems, I think, have trouble mostly because of the lack of knowledge of what a pulley is or what it does. The idea of a pulley is it just simply is an object that lifts something else. And the way it works is that you attach your item to the pulley. So here we are attached right here. And you put your weight or your object that you want to lift right here. Now what you do is you begin to turn that drum or that pulley. You start to turn it. Now if we turned it 180 degrees, what would start to happen is that this would start to wrap itself around that arc. It would wrap itself around that pulley. So maybe when you're said and done and you've done a 180-degree turn, you've got now a pulley situation that maybe looks like this, because most of your string now is wrapped. It's been moved up. It's been moved up, right? It's been wrapped around the pulley. And of course, what we learn when we wrap something around, whether we wrap it around this amount, or if it came up and it wrapped around this amount, whatever the case may be, if you want to know how much it's moved up, how far it has gone in a vertical manner, your answer is actually found in that arc length, how much has been wrapped around there. Because that arc length represents how much string has been pulled or lifted up. So the key here is this little formula once again. This, of course, is your angle in radians, how much the pulley has turned. This is the radius of your pulley. And this is the arc length, or in other words, how much of the rope has been put on the arc length, which is also the answer of how far it has moved upward. Now gears is the other type of problem. And again, you have to understand how gears work. So gears have these little teeth, right? They have these little tiny teeth. And you have another gear. It's going to be hard to draw correctly. And it has little tiny teeth. Now, what happens is as you rotate, of course, these teeth fit into each other. And that's what the one guy is turning, and the other guy is turning as well. So as the one guy turns, the other guy turns. Now, gears are often, because of effectiveness, a use of energy, and the gear are two different radii. So you might have a small one, and then you might have a bigger one. And so when you are looking at gears, the radius are often not equal. All right. The angle that you turn is also not equal. In other words, if I turned this guy 180 degrees, so it did a 180-degree turn. Would this guy turn 180 degrees? Not a chance. This guy's much smaller. So maybe if I turn this guy 180 degrees, so I do 180 like this, this guy probably only goes about, I don't know, maybe this amount, right? In that same amount of time. Because the gears are different sizes, they don't turn the same angle size. But here's the important thing, so listen. What they do share, what is the same, is their arc length. The amount of arc that this one has turned is the same as the amount of arc this one's turned. And the reason for that is because what they are sharing are those little intersection teeth points. And so if this guy turns a half turn, maybe this guy turns, a quarter turn, this guy might be a full half turn. Or if this guy went once around, this guy might go halfway. So the radii don't match, the angles don't match. But what does match is the arc length between those two. So what you're going to do, let me clear myself a little space here. What you're going to do is, let me get rid of all this stuff here. Basically, you're going to operate with one of the gears, and you're going to use this relationship. And usually you're going to find this number, because you can run over and use that number in the other relationship. Because the part that's the same between the small gear and the big gear is their arc length. The angles will be different, the radii will be different, but what will stay the same is that S value. So my clue to you is find S in the one that you can, transfer that S value over, and then calculate it out. Good luck.